Class, and welcome to Lesson 2.1, Introduction to Sinusoidal Functions. In grade 11, either when you took the 3M or the 3U, we did a unit on sinusoidals, but some of you may have forgotten what that is. Basically, that is a symmetrical wave-like function. Okay, you could take a look at wave-like of sound or of light. They travel in waves, and you may be familiar with that looking at physics. But to introduce, let's use this example of a Ferris wheel and someone getting on the Ferris wheel and taking a look at how this ride happens. So for warm-ups 2.1, it says, draw a graph of a person who rides 2 rotations. That's important to remember, so there's an end to our function on a Ferris wheel that is 10 meters in diameter. So the first thing we can do, folks, is if we know that it's 10 meters in diameter, okay, we can also use that information to help us find the amplitude, okay? And the amplitude is the radius. So the radius equals 10 divided by 2. So the radius equals 5. What does that tell us? That tells us that the amplitude equals 5. The amplitude is how far off or above the axis and how far below the axis does this wave-like function occur. You may remember it as going to your minimum and going back down to your maximum, and that's what the amplitude helps with. Okay? So what we need to do is to remember that when we're sitting down at the bottom, your head is 2 meters high. So pretend this is you having some fun. Woohoo! Okay? And you're at 2 meters. Okay? If you're at 2 meters when you start, you're going to go up to the axis. So you're going to rise 5 more meters. So that's going to be 7 meters. Okay, and at the top, you're going to be 2 meters plus the 10, which is 12 meters. And again, you're going to go back down, which is that amplitude difference, which is 7 meters. So think about it. We're going to get on, and we're going to go this way for 2 rotations. All right. So basically, we're going to start it. If you're trying to figure out the distances as we go, we're going to go 2 meters, and then we're going to come up here 7 meters, and then we're going to go up to the top and be at 12 meters. Start coming back down 7 meters. Then we're going to hit the bottom again, 2 meters. And then we have to, that's 1 complete rotation, so we've got to do that again. So we're going to go back to 7 meters, to 12 meters, back down to 7 meters, and then finally end at 12 meters. Okay, so what we want to do is plot those in terms of rotations. So notice with our Ferris wheel here, we put it into quarter sections. So when we take a look at rotations, ladies and gentlemen, we're going to put it into quarters. Okay, so first quarter, second quarter, which is really equal to 1/2. Okay, and we're going to plot this. Okay, so where do we start? At time 0, when we get off, you start at 2 meters. All right, then by the first quarter rotation, you are at 7 meters. Okay, and then halfway through the ride, you're up at the top, which is at 12. Okay, then coming back down, you hit halfway at the axis, which is at 7. And then from the full first rotation, you are back at 2. Okay, and notice this is where it starts repeating, guys, and this is where it's going to be symmetrical. Okay, so I'm going to do, again, I go back to 7, up to 12, back down to 7, and end at 2. Normally, when you graph functions of sinusoidals, ladies and gentlemen, you're going to notice that, first of all, there's a curve-like motion. It's going to hit the axis, the maximum, and the minimum, and back to the axis. But normally, ladies and gentlemen, you put arrows on both ends. But in this case, because it said only 2 rotations, it ends. You don't keep the arrows going. Okay? All right, what else do we need to know, ladies and gentlemen? Just a bit of terminology, just to get us interested here. We know that the top part, that's our maximum. So our maximum height that we reached equals 12. 12 meters, my fault. And the minimum height we reach, which is at the bottom, which is in the trough, which is called minimum. And the minimum value equals 2 meters. Other things that are important to remember when we take a look at sinusoidal functions is the axis. That's where there's equal distance between the min and the max. So this is called the equation of axis. And then, ladies and gentlemen, you can easily see the amplitude that we talked about earlier. The amplitude is from your max to your axis, so that's 5 meters, or it's the same distance between your axis to your minimum, is also 5 meters. Okay, so that's called your amplitude. All right. Another thing we need to talk about is the period. How long does it take to complete one cycle or one revolution? So if you take a look here, in this case, we start at 0, and it takes us to 1 revolution to complete. We're going to be changing that to degrees when we go around circles, so it's not always going to be rotations. All right, from this warm-up, what do we notice? First of all, we notice that it repeats itself. In this case, it repeated itself twice because it asked for 2 rotations. If it asked for 4, you would draw it 4 times. Okay, so it repeats itself. And there's symmetry about it. Especially around the axis. It goes equal distance above and equal distance below. Okay? All right. Let's keep moving on here. So, by definition, ladies and gentlemen, a sinusoidal function is a periodic function. That means it repeats itself, whose graph produces a symmetrical wave. Okay, and it can be a transformation of the 2 base functions, which are y equals sine x or the y equals the cos x function. These are both what we call base or parent functions. By the end of this unit, you'll be very good, or you'll do a good job at making transformations based on those. But let's just, on day 1, not jump to those things, and let's just go back to the basics, okay? So parts of a graph, okay? So taking a look, the cycle is the periodic function, is the part of the graph that repeats. So it's just a piece. So notice here, this is an example of the sine x curve. Starts at its axis, it goes up to its max, back down to its axis, then to its minimum, back to its axis. That is what we call one cycle, okay? The period is how long it takes to complete one cycle. So the period is a number value. So it can be in degrees, it can be a time value, it can be number of revolutions. Okay? The amplitude is half the distance between the minimum and the maximum. Okay? And let me just back up for a second with the period. So, example, a common example is 360 degrees from a parent function. And just remember, it's how long it takes to repeat. Okay, the amplitude I explained on the first one, it's the distance the distance from the axis to the maximum, or you can take the maximum, subtract the minimum, and divide by 2. So to find the amplitude, do a couple things here. It's the max, subtract the min, divide by 2. Okay? You could also find it by taking another way you could think of doing it, but let's answer this case in this case. So the maximum in this case, folks, in this graph is 1, so it's going to be 1 subtract our min, which is -1, divided by 2. That becomes 2 over 2. So in this case, ladies and gentlemen, the amplitude is going to equal 1. Let's take a look. From the axis, which is right here, okay, it goes up 1 for its maximum, and it goes down 1 to its minimum. Okay. The equation of the axis is, I'll just put it here in green here, guys. So this is the equation, okay? And in this case, it's y equals 0, okay? And it's going to depend on your transformations. If you shift up or down, that's going to shift with it, okay? And notice that the equation of the axis is always halfway between the min and the max. All right, then we're going to be dealing with domain and range. So domain deals with all the x values involved. Usually its domain is such that x belongs to a set of real numbers. And there's usually not a restriction, because when you do a wave-like motion, normally the arrows indicate that they continue on as far left and as far right. Okay. However, if they say for only 2 revolutions or 3 revolutions or 3 cycles, then you have a starting point and a definite ending point. Okay, but in most cases, that's going to be that. For the range, ladies and gentlemen, that deals with your y values. So range makes y belong to a set of real numbers such that, and in this case, we take a look. How far down? So you start with your minimum. So our minimum is -1, and then to y, and then to its maximum, which is +1. So remember, it's your minimum value and your max value. All right. Okay, and the intervals where the function is increasing and decreasing are. So first of all, increasing, take a look at this example. When is it getting bigger? Okay, so it's between 0 degrees and to x to 90 degrees. So it's getting bigger. And notice that it also gets bigger from 270 to 360. Okay, when it's decreasing, ladies and gentlemen, okay, that's when it's going down, and you'll notice from 90 degrees to x to 270 degrees, it's decreasing. All right, later on, ladies and gentlemen, I'd like you to come back and plug in this website. You can copy and paste it and watch that video. But right now, we're going to get into doing some graphing of sinusoidal functions. So taking a look, ladies and gentlemen, to graph these, we want to take a look at what's called a unit circle. Okay, so a line segment, so notice this line segment here in red, I'll just highlight it in blue so you see what it is. It's got a unit of 1. So 1 unit long, and it rotates about the origin. So basically, ladies and gentlemen, this is called what's called a unit circle. Okay, which is down below here. Okay, so the radius is 1. Okay, so list the points that the end would pass through each of these angles. So first of all, if we start at 0 degrees, so if you think about your terminal arm, ladies and gentlemen, just change color. 0, you're right here. So what's the ordered pair there? It's 1 and 0. Okay, so your cosine values, if you take your calculator, you go cos of 0 degrees, and you'll find out that equals 1. Whereas sine of 0 degrees, okay, you're going to plug that in, and that's going to equal 0. Okay? Then we go to 90 degrees, so up here. Okay? At 90 degrees, our point is 0, 1. Plug that in your calculator, you get a cos of 0, and you'll get a sine of 1. Okay? Next, we'll do 180. So at 180, we're over here. So our point is -1 and 0. And plug those in. So you're going to have cos of -1 is -1 and 0 for sine. Okay, 270, we're down here. Okay, so for 270, ladies and gentlemen, our ordered pair is 0 and -1. Plug in the cos and the sine for that degrees, which is cos of 270. So cos of 270 is 0, and the sine of 270, you plug in your calculator, is going to be -1. And remember, the reason we're seeing negatives here, folks, is because you got to apply the cast rule. Okay? As it affects those. All right? Then we come back to 360, which is the exact same point, which is 1 and 0. You're going to have the same results, ladies and gentlemen. You're going to have, for 360 degrees, you'll notice that the cos of 360 is 1, which equals the same as the cos of 0. Same with the sine of 360, that equals 0. Okay, and then you'll notice, ladies and gentlemen, we kept going. So 360, we add 90, 450, we go back up here. So keep going around. So one more complete rotation. We're just repeating itself, guys. So it's the same as 90. And I'm showing you why it's cyclical and why there's a pattern, because we keep rotating around the same circle. So 540 would be the same as 180. So it'd be -1 and 0. So it's going to be -1 and 0 when you plug those in. And finishing this off, 0 and -1. Okay, that's the same That's the same, ladies and gentlemen, as 270. So that's going to be 0 and -1. And to finish off, we're back to our original starting point, which is 1 and 0. And again, you're going to have 1 and 0. What this, folks, shows you is that it's cyclical when it rotates around a circle. Okay? Now, one thing about the unit circle, guys, just remember that a unit circle has a radius of 1. When you do tonight's homework, and I'm just going to show you quickly, I believe question 1. So for the homework number 1, you have a circle in your homework with a bunch of degrees on it. Okay, so the first one says, hey, what if this is 30 degrees? So if it's 30 degrees, we know that's a special triangle, folks, and I'll just quickly draw it here. So 30 degrees means we would have 2, 1, and root 3. If not, you should have something on the sideboard from last unit, or you should remember from last unit, that's how you do a special triangle. And it asks, ladies and gentlemen, for this point. Okay, so this point, as my triangle is drawn, ladies and gentlemen, think about the x-coordinate. The x-coordinate there is root 3. Okay, and the y-coordinate would be 1. So just think, from here you've translated over root 3 and up 1. However, this is not a unit circle, so you have to transfer it to a unit circle. So, but for unit circle, we've got to do a little bit of adjustments here. And sorry, I just drew that a little too large. Okay, so for the unit circle, ladies and gentlemen, let's try that again. Sorry, you know better than that. Here we go. So what we need to do is remember we got 30 degrees here, okay? And instead of having 2 here, I need a 1. So what did I do? I had to take this and half of it. So each of these sides are going to be root 3 over 2 now, and this is going to be 1 over 2. So this point, and this is where you're going to do your homework, ladies and gentlemen, where does that point come from? That point's going to be root 3 over 2, comma, 1 over 2. Okay, that's the point that you get the answer from. Remember that you've got to transfer from your special triangle to get a, so this takes it from the special here to a unit, makes it 1. Okay, so basically you divide everything by whatever your hypotenuse is to get 1. All right, I'll do one more just example. I know the next one is, I think, 45 in your unit circle. So it says 45 degrees. So again, we can transfer that over here. What do we know about our special triangle with 45 degrees? It's 1, 1, root 2. So this point, if you were just to leave it with the special triangle as is, would be 0.11. But that's just a special triangle. But to get it to a unit triangle, we need to make sure, or sorry, a unit circle, instead of having root 2 on the diagonal, we need to have 1. So how did we do that? We divided it by root 2. So what does that mean? That means that both my sides also have to be divided by root 2. So to finish off with this one, to get this point, ladies and gentlemen, this point has been pushed over 1 over root 2 and pushed up 1 over root 2. So that's how you get those points. So that's number 1 for tonight's homework. I just thought I'd tie that in. All right, to finish off the lesson, let's just go over these base functions and remember how to do this. Okay, so these are what we call our base functions or parent functions, and there's 2 of them. Okay, so you can draw a graph. If it says to describe give the equation for the transformation, you can use cosine or sine depending on whichever one you want. Remember, ladies and gentlemen, that these are parent functions, so the transformations of A, K, D, and C, just like what you remember from before, they will come into play based on the parent function. And we'll go through those as we get going. But to remember your basic formulas, I want to just express these separately. So cos x, you always start at your max, and you go to your axis, then you go to your minimum, then back to axis, and lastly, you're up at max. So there's 5 key points, okay? And notice, ladies and gentlemen, that because it's a parent function, that means we're going to start at our maximum. And in this case, we're going to go 0, 1, and 2 because it's a parent function, so -1, -2 for our scale. Okay, so we're going to start at our max, which means in 360 degrees, we have to go back to our max. Okay? So if we start at our max and end at our max halfway through, which is at 180, we have to be at our minimum, which means that halfway through there at 90 degrees and 270, we are back at the axis. Okay? So with our parent functions, they go curved lines. I'm not expecting perfection with these curves. Just try as much as you can. Okay? And again, if you wanted to keep doing this, you could do 2 cycles, 720 and 540. Okay. And if you're not sure where we're getting these values from, also, we just did that the graph we just did with the table on the previous page. It tells us exactly what points we're at, okay? So it's 450, and the last one was 630. Okay? And notice here, ladies and gentlemen, I'm putting arrows on both ends because they continue. But for the purpose of this course, I will always want you to box in one cycle. So where it starts and where it ends in terms of one cycle. So we call this the one cycle box. Okay? All right. So just remember that when we're taking a look at this, that when we're talking about the xy coordinate, okay, that it's y equals cos of x. Okay? That's the cosine. Notice it starts at its max and it ends at its max. That's different than the sine parent function. Okay? So change colors here. And if you want to be colorful too, I'd recommend it as well. Okay? Now the thing with the sine x, if you look at our chart, ladies and gentlemen, it started at our axis because we had a value of 0. So it goes axis, max, to our maximum, axis, min, back to axis. All right? So let's do that. We start at our axis, and at 360 degrees, we're going to be back at our axis. So what we need to do from there is at 90 degrees, we need to be at our max. At 180, we are back to our axis. And at 270, we are back at our min. Okay? Okay? And then if we want to do another revolution of that, ladies and gentlemen, we would be back up at 420. Just trying to read my, I'm sorry, at 4, I'm just going to go back to my chart here, 450. Okay, so back up at 450. Okay, and then 540. Back down at 630. And back up at 720. Okay, so when I draw this, ladies and gentlemen, remember, try to do it as curvy as you can. Takes a lot of practice, I know. Okay, and it continues on in both directions. And again, box in one cycle box, so where it starts and where it ends. That'll help you later on if you've developed that. So this is the one cycle box. All right, so those are the two parent functions, ladies and gentlemen. That's where we're heading. So now we're going to get ready to do our homework. So I listed on the last page here, homework page 24, 25, number 1, that's the unit circle one I went over. 2, 4, and 8, remember to use special triangles for exact values. So on my website under the Math Useful Tools, you can click a thing that says trigonometric paper and you can print it off, or you can use this grid right here for your homework and print it off. Okay, you need to be using something that has appropriate scale on it, so I wanted to make sure you have that for you. All right, good luck with today's homework, ladies and gentlemen, and please see me if you have any help. Have a fabulous day, folks.